Pia Wische is the CEO and LCA leader at EcoEd, which is a Chilean-based company dedicated to orienting decision makers with reliable and science-based data to manage sustainability. And now in her case study, you will hear and see the full LCA of a refurbished high-end smartphone and the environmental benefits of it, it entails. So Pia.
Well, it's a pleasure to be here and show you the results of a life cycle assessment we did on a refurbished cell phone in Chile. And this is a cell phone you will probably all know. It's an iPhone 8, 64 gigabytes. And we've done some things differently with this study. The first one is that we are being completely transparent on the results because we want to move industry forward to a more sustainable way of producing both hardware and software. This is our goal right now. This is the impact we want to have with this LCA. And I will show you now some of the results. You can see the full report, unfortunately only in Spanish, but you can see it on the link that is on the slide. A small word about EcoEd. We are a technology training and consultancy company for lifecycle decision making. We use science to orient our clients, and we take it very, very seriously. Let's talk about the impacts on the lifespan of a smartphone. From references, right? We know that approximately 4,500 million tons are discarded globally of electronic materials. We know that one single unit can produce 40 kilograms of carbon dioxide equivalents and require over 600,000 liters of water for their production in the whole life cycle. So it's a big impact for each cell phone that we buy. So you start thinking, how long have I had my phone right now? And when will I change it? And I hope that is longer than 5 years, unless you're buying a refurbished phone. With this study, we wanted to estimate the environmental impact of a refurbished smartphone, identifying the elements with the greatest contribution to different impact categories in the life cycle and determining the difference of the impacts between the refurbished smartphone and the new one. And here we could only compare the carbon footprint because that is all that is available publicly. Here is the full life cycle. We have the production and import of parts. We have the refurbishing, the distribution, the use and the energy and the waste of the packaging materials and everything, and the end of life of the smartphone. So we were very thorough in having as full an inventory as we could. We tried to consider everything to figure out what was most important. We used a cutoff logic, so and the functional unit is the daily use of smartphone for 3 years, including video, audio, and internet. So this is how we calculated and estimated the energy use. The methodology, of course, ISO standards 1440 and 14044. We used OpenLCA with EcoInvent 2.2. You will see it's a little bit old, but it's what we had at the moment. We had primary data from year 2020, which was fantastic. And we used Recipe to analyze our results. And also CML in order to compare with another, with a modular phone that you will probably know. It is, it's a European smartphone. I will remember in a minute. So let's see first which are the elements with the greatest contribution to different impact categories in their life cycle. And overall, from the stages, from the 5 stages of this refurbished cell phone's life, we could see that the most impactful stages were the production and import of the materials to do the refurbishing, and also the use. And the use was the most important. And you will see in a minute why. The graph is small, but what we want to tell you here is that all impacts behave differently. So when you're analyzing an electronic material, you can't really take out any of the impact categories. And this was already described by other authors, Moberg et al., already a few years ago. So it's important to look at all impact categories because everything in the life cycle impacts differently. But overall, the use phase here with the green, dark green bars And the production and import with the light green bars were the most important in each category, although they behaved differently. We determined the difference of a refurbished smartphone impacts in relation to a new one with the same specifications. And as I was telling you before, we could only do this over the material usage, which for the refurbished smartphone was only 13% compared to the new iPhone, and also on the carbon footprint, which was a 71% lower carbon footprint. So you see that this is a very interesting result. Considering the numbers, if you love iPhones, keep it for 4 years or more, or either get a refurbished one so that you minimize your carbon footprint over the years. This is the material usage is related to the parts that were replaced in the smartphone. Also, if you want to get rid of your smartphone, maybe you take it to a refurbisher so that it can use it again. When trying to draw conclusions over what was more sustainable, either the modular phone or the refurbished smartphone we were analyzing, we realized that we couldn't really compare. We calculated the uncertainty of our study, which is not here, but it's in the report. But the report from the modular phone did not have the uncertainty. So we are not sure, for instance, if in here the abiotic depletion potential, which smartphone is better, or the same thing for human toxicity and terrestrial ecotoxicity. It could be very different depending on the uncertainty of the two studies. So one big message we wanted to bring to the community is that when we are calculating the impacts of any product, we should always report on the uncertainty so that other studies can make a fair comparison. Or even just so that we know what we cannot compare or draw conclusions on. Overall, reusing the material substantially reduces the impact because of avoided production, and this might be interesting for Bosch. I was looking at another presentation from the company under reuse of some components. So they are not recycling, they're not destroying the component to build it again, they're just reusing the components as they are. And this is what brings the impact so low. The country's electrical mix and the user's consumption habits can significantly increase the product's life cycle impacts. And this is quite important because in EcoEd, we don't necessarily have the best mixes for electricity in each country. So if you're analyzing one country, it might be better to make a deep dive on the electricity mix of your product or the energy mix for your country and fix that in the database before you go to conclusions, especially if it's as important as it was in our study. And calculating uncertainty absolutely enables the comparison between studies and circular models. So I will be looking forward to your questions now.
Yeah, thank you for your talk. It's really interesting. And we already have 2 questions in the chat. So please, audience, if you have questions, just type them in the chat and I will ask Pierre about
Teal,
it. So
thank you very much. I was talking about the Fairphone.
Yes. So the first question comes from Joachim. So the question is about allocation. Did you allocate the production of the new phone to the second use? If yes, how did you allocate it?
No, we couldn't, Joachim. And this is why we used the cutoff logic, because we considered that the first life cycle didn't carry any impacts over the second life cycle. But we did consider all of the logistics required to bring those cell phones in from all over the world over to Chile and all the refurbishing process. So, and we couldn't do this. We would have loved to do this, but we couldn't do this because data was not publicly available. We are not even sure if the company has the life cycle data for all of these impact categories. So we couldn't do it. That's why we chose cutoff.
Mm-hmm. And the second question comes from Tom. Which part of the smartphone contributed most to the impacts? Was it the casing, battery, screen? What was it?
Perfect, Tom. And this is where I want to cite on Moberg again. And this is why I was stressing the need to look at every impact category, because different components affected different impact categories in a different way. So we had the battery. It was important in some impact categories. The screen changes were important in others. The casing, not so much really. And the ICs, so the integrated circuits, there were not, because of the quality of the phone that was chosen to be refurbished. There are different qualities of waste phones. They use the highest quality. So normally they don't really have to change the motherboard or the integrated circuitry. So that was not really considered, but it was the battery, the screen, and the casing, which were considered most, and mostly the battery and the screen, depending on, especially the screen was important because it had flight, it was transported by air. So this gave most of the impact to the screen, as well as the production process, because it has a lot of layers. So, but it depends on the impact category, so I can't really answer that one.
Mm-hmm. And then I might have a question as well. So, of course, I know your talk was about refurbishment of smartphones. I know that from Markus Reuter, for example, they conducted a study about the recyclability of smartphones, and they saw that, for example, the Fairphone uses too much modularization, that actually recycling-wise, less modularization is better, because it's also from an environmental perspective more like an environmental overhead due to modularization. What do you think about it when it comes to refurbishment? Because I think it eases the replacement of certain parts. It's more modular.
I think recycling should be our last option. When we teach our clients about circular economy, we always tell them that recycling is the worst of the options in circular economy. Well, before just burning things, because you actually have to destroy the piece, you have to destroy the material, and then rebuild it again. Whereas in refurbishing, you reuse the parts as they are, so you skip a lot of steps in the life cycle of these materials. So perhaps focusing on the recyclability of materials is not as important as focusing on how long we will have them in use as they were produced in the first place. And this has to do with software design. So we can't kill our hardware because the software won't have it anymore. And this also has to do with the hardware design, because it has to be made to withstand the future at the speed that we know that it's coming. So it goes hand in hand, and we need the different actors in the industry to work together in order to keep phones functioning for longer. That's the end goal.
Mm-hmm.
Okay. Maybe, Thorsten, there are some more questions in the chat, but for time reasons, we may need to leave it here. But it would be appreciated if Pia could take care and respond via the chat or in another way to the pending questions.
Will do.
Thank you, Joe.